Hello. We are back this time with a question from section 14.6, the question 12 of the book, which says find the directional derivative of the function at the given point in the given direction. So let's first see what was the directional derivative. If you're trying to find directional derivative of a function in the unit direction u at the point AB, so if u is unit vector, then we know that this is equal to gradient of the function f at that point. Then you dot product it to the vector u. So this is something we have to know to start to work with this question. Okay, so the first step then is to find gradient of the function f. So first I'm going to find for general point, then I'm going to plug in the point 1, 2. So what is gradient? Gradient is a vector whose first component is partial derivative with respect to x, and the second component is the first partial derivative of f with respect to y. So then we are ready to go. We have to find partial derivative of this function with respect to x. I have to use the quotient rule, which says derivative of the numerator times denominator minus derivative of the denominator, which is 2x, times x times numerator over x squared plus y squared over denominator squared. So that's first component. The second component is the same thing, but this the derivative of the numerator with respect to y is 0 minus derivative of the denominator 2y times the numerator over. So that's my function's gradient. Now gradient at the given point, which means this point, x is 1, y is 2. So I have to plug in values for x and y. For this guy then I have 1 squared plus 4, 5, minus 2, it is 3 over 1 plus 2 squared is 4, 5 squared is 25. This part is 0, 2 times 2, which is 4, negative sign times 1, negative 4 over 1 squared plus 2 squared, 5 squared, 25. So that's my gradient at the point 1, 2. Now the time is to find this part, v. Note that to find directional derivative, we have to check that the vector we have is unit. Or, as the question says, we have to find the direction of the vector. So the direction of the vector v, okay, the vector. So basically you normalize it. So you just get rid out of the length of that vector by dividing the vector by its length. So here I have 3, 5 divided by its length, which is 3 squared plus 5 squared. So this whole thing is now direction. It is going to be unit vector, and that's my u. So my u is 3 over, this is 9 plus 25. This is 34, square root of 34, 5 over 34. Now I have both pieces. Gradient at that point, I have the direction. So directional derivative of my function at the direction u, the given point 1, 2, is equal to gradient at that point 3 over 25 minus 4 over 25. Dot product to the direction, to the unit vector. So dot product, we all know you multiply the component, corresponding components, and add them. So I have 3 times 3, 9 over 25 root 34 minus 20 over 25 root 34, which gives me minus 11 over 25 root 34. So those were the steps. We find the gradient. At that point, we make sure that the direction is unit vector, and then this is the formula. Thank you for your attention.